Today, we will learn how to label a right-angled triangle, and we'll also learn how to determine which trigonometric ratio to use. So to label a right-angled triangle, there are three definitions we need to have, and they are hypotenuse, an opposite side, and an adjacent side. Alright, so a hypotenuse is the side opposite your right angle. It's also your longest side. Remember, you do need a right angle in order for the hypotenuse to exist. Your opposite side is the side opposite your theta or your angle. Right, so we're not talking about the right angle this time, we're talking about the other angle that we are labeling. So the opposite side is the side opposite. And for those of you that like your English and your I guess your fancy words for saying things like next to, right? Adjacent is just the side that's next to your angle, which is why we have this little arrow pointing to the angle next to it. Now keep in mind that the hypotenuse is also adjacent to the angle theta, but it's got a different name. It's called the hypotenuse side, right? Whereas this adjacent side is called the adjacent side. So just a little piece of information there that we're going to need to be pretty comfortable with using. So now we're going to look at an example. So for the triangle alongside over here, we want to name the hypotenuse side opposite to theta and the side adjacent to theta. So the side that is the hypotenuse is the opposite. So this is your hype or your hypotenuse. Your opposite side is the one on the other side to your theta. So that's your op. And then your adjacent is your last remaining one, which is just next to your theta. So I'll give you a moment to have a think about the ones at the bottom of this screen. All right, pause the video, and then I'll write down the answers, and you can check your work. All right, hopefully what you see on the screen is what you actually got. So now we are looking at trigonometric ratios. So in any right angled triangle with one angle theta, we have that sine theta is equal to the opposite over hypotenuse side, cos theta is equal to your adjacent over the hypotenuse side, and your tan theta is equal to the opposite over adjacent. Now just a few things on pronunciation. All right, sine is pronounced like sine, like a letter post sign. It's not sin. It is not sin. It is sine. Right, you also have that cosine is pronounced like cosine, and then tangent is tangent. All right, so the one that's the most, I guess, said the wrong way is your sine theta. So just remember it is sine. Okay, so then you look at all of those equations and you go, how am I ever going to remember that? Well, the good news is that there's a thing called SOHCAHTOA. All right, you might have heard of it before. All right, I've got it written down along the side here, SOHCAHTOA. And what it stands for is we have sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. And the way that this works is in all of them you have sine, so S O H, so S O H. And then you have C A H, and then you have T O A. So in every one, it's going first letter equal to second letter over your third letter. All right, so that's a good way to remember it all, and a fancy way that I remember still, even when I was taught it back from when I was in school. So let's look at an example. So I have a triangle here. All right, for this example, we don't have all the information, so let's call this last value on our hypotenuse x. All right, you could label it whatever you wanted. So if I want to find sine, cos, and tan, well, the very first thing I need to do is I need to label my sides. So very first off, our side opposite, this is going to be your hypotenuse. The side opposite my theta is going to be my opposite, and then my adjacent is the side just next to it, so I know that this is my adjacent. So next up, we need to find sine. So what was our little memory trick for sine? Well, it was so. So in that case, I need sine theta is equal to my opposite, because that is my top one, over my h, which was our hypotenuse. So in this case, I have sine theta is equal to opposite, so the side that's opposite my theta is 4, all over my hypotenuse, which is x. Alright, and that's how we would write our trigonometric ratio for sine. Alright, well let's have a go at cos, and you're welcome to have a go at these yourself before I do them, so pause the video, have a go, or you can just continue on and watch me go through this example. So the next one was cos. So that was car toa. So car is where we had our CAH. Right, so again, like last time, we can write our trig ratios in using this little shortcut. So I know I have cos theta is equal to my A, which is adjacent, all over my H, which is my hypotenuse, because it was my third letter. So then I can just put in the values I have for those things. So cos theta is equal to my adjacent, which was 3, and my hypotenuse was x. We didn't know what that was. Alright, and now we're done with cos theta as well. So one more to go, and that is our tan. So tan was car toa. So we have TOA in this case, so toa. So I've got tan theta here is equal to my opposite over my, well, I don't have hypotenuse this time, I have adjacent. So we're going to put adjacent on the bottom. So then if I was to write this out in full using the values I know, I have opposite, which was 4, and I have my adjacent, which was 3. And that's how we write all of our trig ratios. So remember, car toa. Super handy, super useful. If there's one thing you have to remember out of this topic, it's car toa.